Hello friends, welcome to TRX Bench. Well, here today on the bench we have a ICOM IC-910H, and this radio came in with intermittent receive problems. So the owner claimed that after a short while this radio is not able to receive FM signals on the main channel, but when he then switch it to the subs channel or sub receiver, then he said he has a fine and clear and crisp receive. So something seems to be wrong with at least the main receiver, and first of all, let's verify if we can find the same, and then let's see what's really going on. Okay, so radio is connected, and we are right in our video, so let me fire it up. And so we can already see there is a signal, and yes, we can hear it. So this is FM right now, and of course I have no signal for the moment in time on UHF, so I can switch it. Now my signal is on the sub receiver, and you see I receive the signal on both receiver paths. So actually this radio has really two independent receiver passes inside. We will see it later on the block diagram. And I can see I can receive FM, and when we switch it to SSB, of course I have to switch off my deviation for FM for sure. And now you see it is working on SSB, so just fine. Yeah, I hear a little bit the tone varying, so that is because of course the radio is still cold and the main oscillator has not stabilized yet. Anyways, let's go back to FM and let's switch back my deviation here, and so the only thing I can do right now is leave it run until our receiver fails, because then we can do our first checks, and but up to that point we simply have nothing to do, because we need to see the fault to start our investigations. So I leave it right now run, and I will be back until or if we see the fault. Okay, and finally the tone is gone, so the radio has failed. Well, it has taken longer as expected, so approximately 3 hours it was running just fine, but now you see the signal is gone. Nothing has changed with my signal generator, so everything is as it was. And you see our S-meter is gone as well, so we do not have any indication. And when I now switch it to the sub receiver like so, you hear that now we can receive our signal as we were able to do it before. We can receive it on the sub receiver still. And back here to the main receiver, you see it is not present, the signal. Well, so first of all, let me switch it here to SSB, and you see suddenly we have here back our S-meter strength indication. So that is telling me somehow we get the signal to our S-meter amp, but that is not really will lead us to a conclusion. But let me see when you see, if I really turn it up, the audio, if I really turn up the audio amplifier on SSB, you can barely hear the audio in the loudspeaker. That means, it is reduced, and our signal to noise is much weaker than it was as long it was working just fine. So we really have lost a lot of signal to noise, or better said, SYNERT. And as you can hear, it is now really full power. But anyways, this is telling me that all the signals from our local oscillator board, or from our PLL circuit, must be present, because otherwise I wouldn't be able to hear this signal. But maybe that this local oscillator signals are reduced, or that the signal is lost somewhere, I don't know. But when I switch it back, so you hear that the audio amplifier is working fine. You can hear it from the beep here. So you really hear that the audio amplifier is fully working. So that is not the problem. But you see, there is nothing. So let me first of all connect to the radio an UHF signal. And we know this radio has both inputs. So of course we have a VHF input and a UHF input. And okay, I'm here on 430-100, and my signal generator, my second one, which is down there, okay, is also set to 430-100, and I will now switch on my RF signal, and then I will switch on my tone. But let me do it while we are looking here at the radio. First of all, signal, and so you directly see that we have signal. And now I switch on tone, and let me see. All right, and I've chosen a 400 Hertz tone so that we hear the difference. Of course, I can switch it to 1 kilohertz, and you hear it is working. And I'm interested, and we are on the sub channel, of course, and I'm interested, is this signal here from my UHF generator, is it present on, or can we hear the tone at least on our main receiver? And what we hear right now, so that is our VHF signal, so I have to turn it down. So we do not want to hear our sub receiver, we want to hear the main receiver. And you see, we have the same problem on UHF like we have it on VHF. So when I switch it over now, right, you see nothing on VHF, but now this here is our, and I put it back here to 400 Hertz. So we always know this tone here is the tone on UHF, and when we now switch it here over, you hear 1 kilohertz, and that is now our VHF signal on subreceiver. And you see there is definitely no receive here on our main receiver, okay? And of course the next step is now to find a starting point. So where to look first to indicate what's really going on. And well, our block diagrams are here in 3 pieces, and we need the main unit, and we need of course the PA and PLL unit. Why do we need our PA unit? Because we are working on receive. So let me zoom in here a little bit. When we see, for instance, here our antennas, I hope you can see it. Let me zoom in a little bit more. So you see here our both antenna inputs, and let us follow here the receive path through, from the antenna input. Our signal path is going through our PA board, and that is what we can see here. So right here, this here, all along here is our receive path, and the interesting part is really here on the PA board, because there we have our first mixer, right? So you see here is our local oscillator input from our VCO for VHF frequencies, and you see a local oscillator amp, and you see that the local oscillator is here at the mixer. So that is interesting to know. And on the other hand, if we follow along our UHF signal, you see basically is exactly the same, right? So of course we have here our TX RX switch, so that is clear. But we are interested in RX, of course, and we follow here along, and we see here our first mixer, and so here you see our UHF local oscillator, which comes here to our mixer, and on the UHF path we have a second mixer already here on the PA board, and therefore of course there is a second local oscillator already on the PA board, which is mixing here the signal down to I believe somewhat around 10 something megahertz. So and they need here 2 mixers already, because we start off from 430 whatever, right? And to get down to 10 megahertz, right, they decided to have already 2 mixers on the PA board. Then of course we have here our PLL unit, and the PLL unit is for producing our local oscillators. And you see here, this here is our VHF LO, and this is our UHF LA, and it is the first LO, and you see this here are the VCO frequencies which are produced in the VCO, and then they are directly connected to the mixers. And then additional to that, you see here our second local oscillator for UHF, so that is what we have seen before. And of course we have here some LO, so LO3 or LO2 for our VHF pass is also present here. So this both oscillators here, local oscillators, are used on our mainboard. And yeah, saying mainboard, so therefore we need to go here on our main unit, and just to understand it a little bit, so you see more or less two identical portions. So we have here a portion which is identical to this portion here, and what we can see here is, so this here is our main receiver, and this here is our sub receiver. So these are really our two receiver passes, okay? And yeah, well, this here is all the switching and squelch and AF amplifier and yeah, speaker and switching from the sub receiver to the main, and yeah, from the main to the sub to the main, whatever we want to do. So that is what we have here. All this switching here, all these relays which are here in the pass. But important, really important to us is that we have here our sub receiver, and this here is our main receiver. And this is now important because here we have, as long we are talking about VHF, this is our second LO input, right? And what we can see here, this mixer here is for SSB, and you see before this mixer, right, we have here our meter amp, and that means our signal will be definitely present at that point, because otherwise, on SSB of course, because otherwise, let me enlarge it a little bit more, then it might be easier to see. Maybe this way. So right here is definitely our signal present, because here's our meter amp, and we have seen on SSB that the S meter is indicating the signal, therefore it have to be here. And on the other hand, we were able to hear the tone on SSB, not very strong, but it was present. So therefore this mixer, yeah, is working in some way, and then the signal is here connected to the AF selector, and then to you know, the audio pass at least. And therefore in some degree this all seems to work, but what definitely does not work is here this mixer, or I don't know if it is a mixer, but you know, this here is our FM IC, and we see here from our IF amplifier, we have here this these filters here. So this is a SSB filter, and this is a CW filter, and we have no filter for FM, and the signal then will directly go here to this IC. So this is the IC-401, and yeah, we have here our FM mixer, and remember, we really didn't see a meter indication, S-meter indication, and if we see here our IC-401 with a FM detector inside, we see that the output here from this IC goes to the meter amp. So that is telling me that somehow this signal is not present. And the question is it because, yeah, is there a lack here of this local oscillator, or is here something wrong with our switching, right? Because we need these diodes get switched while we switch onto FM, otherwise we won't have a signal here. So is that a problem, or you know, is in some degree the IF amplifier, when the fault occurs, is the IF amplifier not working in some degree, or is our automatic gain control wrong? So where does it really comes from? So I guess a good starting point is to see what this local oscillator is doing, to see if you know, if we have a change here in the signal strength for instance, right? Or is it more here into the direction of the IF amp? So therefore I think a good starting point might be to look out here for our local oscillator. Is this local oscillator present at our IC-401? And the good thing, by the way, is as we have two identical passes, right? We have more or less the same, our IC-951, okay, is, you know, the same IC for our sub-receiver. And we have here our sub-receiver local oscillator, and we can check if the level of this, both the BFOS and of course for our main receiver our BFOM is identical from the level. So that might be a good starting point to get a feeling where our problem could be. And then of course we really need to step here through the circuit and see where we really lose our signal. So why we have here a FM detector which is obviously not working. Is it a voltage problem, or is it a local oscillator problem? Is it a switching problem? Is it a IF amp problem, or is it a AGC problem? So you see, there are really more than one possibility what really can be the case for this fault. Okay, so let's go, crack the radio open and see that we get access to our circuit that we really can start measuring. Right, and I've taken off the bottom lid, and what we can see here, so this here is the SHF module. So this radio is also capable for SHF, so it is not only VHF and UHF. So this has the SHF option implemented here in the radio, and yeah, it is quite hot, so it is really hot. and below this shielding here we have our PLL unit, and of course here below our HF module we have our main board. So first we need to take our HF module off, and we need to take here our shielding off, that we have finally access to the PLL unit and to our main board. Okay? To get here our SFH module out is not very difficult, so we need to disconnect here our coax cable from the local oscillator, and then I've taken off here 4 screws, and now I can lift it, and can you see it? Yeah, I can here now disconnect our power supply, and of course here is a ribbon cable which we need to take out of our main unit, and you see now I have already access here to the main board. And well, you know, this module is really quite hot, and all the heat goes of course here to our main board, and you know, this is really not so easy if all the you know, the hot air can't really get out, and if all the ventilation is not that good. So maybe that this is really a problem temperature wise. Okay, and we can here go directly into the testing. Yeah, maybe interesting for you, we have here our filters for the 2 different signal passes, receiver passes. So our SSB filter, CW filter, the same we have here, and we have down here, this here is our IC401, which is for our main receiver, the FM IC, so you know, our FM detector and what have we. And the same is here for our sub receiver. And I've shown you that we have of course 2 local oscillators which has to be present for our mixing here in the sub pass and of course in the main pass, right? Therefore we have of course our both local oscillators, and as I said, this here, this is our PLL board, and we get from our PLL board here the input for our main pass and here for our sub pass. So we need to have here a frequency somewhat around 10 point something to be able to get down to 455 kilohertz IF. And yeah, the first we do, and that is what we said before, let's check if these local oscillators are present. Therefore, I have already switched on my scope. Let me here connect my probe, and then when I go down I should be able to read something, but therefore let me readjust the camera that you will be able to see the scope screen. Okay, so you see the screen, and I go now and test our sub local oscillator, and we see, yeah, so that is as expected. You see here our oscillator, local oscillator frequency, and we have 10.495. So that seems to be just fine, and we have a voltage of about 200 millivolt RMS, which seems to be fine as well, so no problem with that. And just to go over that, you see where I am. That is what I said before. We directly check out the frequency here at the input. And now we have, as we said, exactly the same here. And we should be able to read here our main. So that was sub and that is main. And we should be able to read here our main LO frequency, which should be 10.395 or something. And I'm already down here at oh, sorry, you can't see it, sorry for that, but yeah, there is a connector which is completely similar to the sub. This is the main, and you see I'm already down here. And let's see what we have on our scope. And what you can see is nothing. Wow! Is that already our problem? Is the problem really that we have a missing local oscillator? So yeah, that would mean that most likely it is everything fine here on our mainboard, except from the fact that we have here a missing oscillator, local oscillator frequency for our FM mixer IC. Okay, and I have pulled off here our connector. So this here is our local oscillator, and I just wanted to check it here directly on the pins to make sure that the signal, which should be here present, is not pulled down by a problem on the main board. And yeah, I can already tell you there is nothing on here the screen, so nothing. So I can directly put here this back to the connector somehow. Okay, and I will do the same here with this. I pull it out, so this is our good one, as we know, and it is connected, and have a look. So signal is present, so that means that you know, our signal is not pulled down here from our main LO, is not pulled down by a fault here on our main board. Okay, so our next test is, so here our oscillator is still out of our connector, and I have here connected my signal generator up there. Okay, so there, and I've set the frequency to 10.39 megahertz, which will be our oscillator frequency, right? And let me now inject this frequency here into our circuit. By the way, it is of course 200 millivolt RMS. So let's see. Aha! So you see, when I inject my LO frequency here into this connector, the radio is directly working. So that definitely means that the mainboard and the entire circuit here is just fine. So there is a problem with our LO circuit, so we have definitely a missing frequency. Okay, and of course next is that we need to take off here the shielding, that we can really get access here to our oscillator output and see what we can find down there. Okay. Okay, and on the PLL unit we are talking about this both local oscillators, and the IC-701 is present, and from IC-601 we do not have our signal for the main oscillator. So something is wrong here in this pass, and when we now change to the board views, we need to go of course to our PLL unit. So we have our PLL unit here, and when I enlarge it, so you see here is our 701, which is obviously fine, and our 601, which is here for our main, is not working, as we know. So that means that something is wrong around here our IC, and it could be of course a temperature problem, so a thermic problem, as we know that the radio is working as long the radio is cold, and then after a while it stops working. So that means possibly it is a thermical problem, a temperature problem here on our DDS board. Our both ICs are shielded by this both shields, and this here is for our sub pass, and this is here our main, for our main pass, the local oscillator. So we have our ICs underneath, and as this one is not working, we need to get off here the shielding, that we have a better access here to our circuit to see what's really going on here. Okay, and as you see, the shielding is open, and our ICs here are free, and the smaller one here, down here, is our DDS IC for our local oscillator, or our third local oscillator, however you want to call it. And the bigger one here is a PLL IC. And well guys, let me tell you, I cannot find a proof for a thermical problem, as I have heated it up here. I've really heated it up like hell, and I used here freezer spray, and I tried to cool it down, and there is definitely no proof for having any temperature problems. So that leads me to the question, is there maybe something wrong on the data bus? Or maybe is a strobe signal not really present, and therefore you can already see it here. I have here 3 probes, and they are connected to clock, data and to strobe. And when the radio gets switched from SSB to FM, this oscillator frequency, which we had found that it is sometimes not working, so this frequency needs to get switched from 10.395 megahertz. You may remember that is a frequency which we injected and found that then our radio was working. That was on FM. And on SSB, this local oscillator frequency is 10.8485. So that is what our IC needs to switch between. And yeah, and of course it is a different frequency on CW and so forth and so forth. So for us it is important to see the switching, and therefore I have already taken the datas. Okay, and that is what you can see here. So the yellow is our clock signal, the blue is our data, and here the purple is our strobe line. So that means this here is the data information to set the DDS IC exactly back to FM, which means we need a local oscillator frequency of 10.395 megahertz, and that is exactly the data pattern which will really switch between, in our case I had it before in SSB and then I switched it to FM, and that is the data pattern, and our strobe signal then is the information to the IC. Okay, take this serial information and just put it to output. That is what is going on here. And well, it is good to have this information, because if now the fault occurs once again, then we can try to take again the data bus information, and it should be exactly as the same like we have it here, and then we can be finally sure that our data, which comes of course from our controller unit, from our main CPU, that this is fine. And I believe it is fine, because remember we have 2 ICs for the main and for the sub receiver pass, and well, if there would be something wrong here with our datas, then our main our sub receiver wouldn't work as well. But as we know, our sub receiver is just working fine, but both ICs are connected to the same data bus, and therefore I believe that there is nothing really wrong with our data bus. Still, as I said, no proof for a thermal problem, so I believe, I presume that there is a problem with the DDS IC. I have done all the testings which are possible, so voltage testing, and is a master clock signal present, and it is, and is a reset present, and it is, so everything is just fine, but as we have seen it from time to time, suddenly we do not have no receive on our receiver pass or on our main pass. So therefore, from the moment in time, I presume there is something wrong with this DDS IC. Alright, and yeah, now it's the time to take some conclusions. I had the radio on the test track, and it was running now for a couple of hours. So we have already the next day, and you know, it was not possible to get this fold back, and yeah, that all is a little bit bizarre, because we said that I presume that something is wrong here with our DDS IC, and well, I still think that really something is wrong. But after I have done all the measurements, and when I was probing here around and pressing it down, and you know, when I heated it up, and when I took here our freezer spray and all this stuff, that means I put, of course, some mechanical stress here on this IC. And yeah, what can I say? For the moment in time, I cannot get back our fault. So the radio, as I said, is now working for hours and hours, and I have switched between the different modes and what have we, and I was not able to really get this fault back. So that really brings me to the conclusion that maybe there is a micro crack here, or was a micro crack. No, it must be there, a micro crack, because of course I have tested it with the microscope, and some of the solder joints are, yeah, you never know. So this is a little bit funny. So now we more or less have three options. First is that we really have a micro crack here around our solder pins of the DDS IC. Or, as I already said before, there is a portion here in this IC which is really faulty, intermittent faulty, so maybe that we really need to change it out. Well, third option is, and that is funny. Let me see if we can get it down here so that you can see it. This pin here, which is, by the way, pin number 44, according to our schematic, this pin should be connected to plus 5 volt, and the 5 volt line goes here under this resistors along, and we can test the 5 volt here at this pin, but normally it should be connected to point 44, but it isn't. So point 44, pin 44 is a little bit yeah, you know, it is connected more or less to nothing, so not to ground or such. It is there is a connection here to this capacitor, but this capacitor is on the other hand connected to plus, so this here is a plus line, and that is a little bit funny, and I show you why. Yeah, this here is our DDS IC. I zoom out a little bit. I hope you can see it this way. And you see here pin 44 is connected here to our plus 5 volt line, which can you see it? Yeah, here, no? So this is here our 5 volt line, and if we follow along here, we can easily see that pin 44, where we, by the way, have the indication VDD, and that should be connected to plus 5 volt. But it is not here in the radio. And the question is this here a drawing fault, or do we really have here a problem on our PCB? And we will not get the answer as well. We will not get it by viewing our board layout. So let me go down here to our PLL unit. So here it is, and this here is our IC of interest. So that is a DDS IC, and as I already showed it to you here on the original PCB, here is plus, here is a capacitor, then we have here one plus line, it goes over to pin 44, and you see that the drawing here on our PCB plan is different to the reality down here in our radio. So this PCB drawing is clearly showing that pin 44 is connected to plus, okay, and yeah, then this C here, this little capacitor, is then connected to ground, and that makes really sense. And once again, when we go down here to our circuit, you may see that it looks here completely different, and there is no 5 volt here connected to our pin 44. So that is bizarre. I have never put my focus on this, and this is the first time that I have a fault like this. So I mean, if it is a PCB problem, normally we should have seen these problems earlier, so maybe that they changed for any reason this PCB, so that it is right that it really does not need to get connected to plus. I don't know. And the problem is, this is a customized ICOM IC. You may see it here. It is really an ICOM customized IC, so I cannot find a data sheet what would probably tell us a little bit more about this IC, so we do not have a better information about it, so I don't know, but still it is bizarre. I mean, okay, I could open now this shielding here, because as we know, we have a second IC down under here, and if the drawing here is exactly the same, or not the drawing, the PCB is exactly done like it is done here on our main DDS IC, then they probably have changed it in a second or third review. I don't know, so maybe that is fine, but for the moment in time it is still bizarre. So okay, once again, solder points, IC itself, or is it really maybe a problem on maybe the early units, on the early PCBs, where they didn't recognize that there was a fault? But on the other hand, then, you know, maybe we would have seen many more of these radios with a similar problem. So therefore, maybe that this is okay. But another interesting information which may help us to decide how to go ahead is this here. So this is the fault description which came from the owner, and by the way, this is exemplary. So that is how I would always have a fault description, because a good fault description is normally half of the repair. The interesting part, I don't show you from whom it is coming, but the interesting part is here in the middle, where our old man is telling that he purchased this radio 8 to 10 years ago, and already when the warranty was over, this fault occurs for the first time. And ICOM had this radio directly after warranty, and they were not able to find the problem. Then they had it once again, they were not able to find the problem, and then recently they had it the third time, this time, and that is, I don't know, only a couple of months ago. And the last time they had it, this radio was 6 months with ICOM, and they gave it back with the information, well, we can't repair it, we found that something must be wrong, maybe in the oscillator, and maybe it is a thermal problem, but the complete PCB is not will not get produced any longer, so we can't fix it, and so ICOM is suggesting to look out for a second unit to repair this board. So that is funny for its own, okay? But anyways, if this fault really was present directly after warranty, so then it might be, because then in the meantime, between these three service visits, so in the meantime it was running, you know, so, and that might be really the case that there is a micro crack somewhere here around the IC. So conclusion, well, that was a conclusion, and action plan is we just reflow this IC completely. After that we will see if the radio will work, and if not, we can still change this IC, but that I would say should then be the second step after we have reflowed it, and we if we are not able to get the problem out of the radio, then we can change and swap out this IC. Okay? Alright, and here's our PLL board out of the radio, ready for reflowing. And yeah, here our little DDS IC, and as we discussed it before, the first we will reflow this IC, and maybe everything is fine, just because yeah, after I have poked around here and there, I was not able to get the radio back into the fold. So therefore let's try to do this, and then we will go ahead. Okay, just finished with the reflowing. Now I have to clean it with isopropanol, and then the PCB goes back into the radio, and yeah, let's see if it works. Okay, so the PCB is back in, and you hear, so our board is working after reflowing. Well, you know, intermittent faults are really the worst you ever can get on your bench, because you never know is it gone or not, and in this case it is absolutely the same. So we finally don't know. So we can hope. I mean, everything is fine, and again the radio is already working for a while, and I have double checked here all around our DDS IC, so it looks fine, but we don't know. So therefore I stop this video here. I put the radio in the test track, and we leave it run for a while, maybe 2 or 3 additional days, just to see what's going on. I mean, if there is not a crack around our IC, if the crack is here somewhere, I don't know, on the PCB, then we are at a point where we really can't fix it. Then we definitely would need another PCB. And the question still is, why did ICOM not swap this PCB when the radio was in service directly after the warranty? So that is a little bit questionable, and now telling, oh sorry, we do not have this PCB any longer. So, you know, I don't know. Well, anyways, we stop it. We hope if the radio is running, then there will be no update. If there is still a problem, we will come back with part 2 of this video. But I think you have already a lot of new information here in this video, and again you see this kind of intermittent faults are really the most horrible you ever can get. Okay, so long. Thanks for watching. I think this video is already really long. I will see when I have it on the cut place, but anyways, if you like it, please give me a big thumb up, and catch you next time. Bye.